Yeah, so welcome back to the channel. Hope everybody's doing well. In this video, I want to take another look at the accuracy issues I was having whilst testing the HT4006 current clamp with the HT65 multimeter here. The readings I was getting when using this instrument was actually out of specification, whereas the calibration certificate that was sent with the HT65 doesn't show any issues whatsoever. All the readings are in spec. So we've set up on the current clamp table. The little current adapter is over there. We are set to 40 amps DC range, and we are on the 10-turn coil. And if we zoom around this way, our instruments are both. These are both set up to the 40 amp DC measurement, and I'm set the key sight up here for reading millivolts and forced it to the 600 millivolt range, which is its most accurate range. And at this moment in time, I've got everything turned off and we're reading 0 as best we can. We are certainly reading 0 on this. There's a little bit of offset on the HT Neptune, but not too much that you worry about. And a little bit of offset on the U128IA that's certainly 0.6.8 of a millivolt, 1 millivolt, so shouldn't be anything to worry about with the offset. So we'll inject 2 amps. And I have been through these readings myself, so I'll just whip through these to get some more stable results. But we'll start to see what we get. And you can immediately see as you go through these, hopefully, that there's good correlation between these two instruments. But this instrument is always reading low. So that's our 20 amp measurement. We'll go up to 2.5 amps. It should be 25 amps. We'll go up to 3 amps, which should be 30 amps. There's our 35 amps. And again, 34.8, 348 millivolts, 34.1. Same theme all the way through these measurements. There's our max range, 40 amps. So 39.81, 398, that kind of matches with the 39.8, but we're only in 39.0 on our HT65. So this instrument has read low in comparison to both these two, that the readings do corroborate across. Okay, so we'll put this table up just to confirm these readings. As I said, I did these prior to doing the video, just to take my time a little bit and allow the measurements to settle. But you can see it's the same running theme, that this HT65 in combination with the 4006 is always reading low and out of specification, whereas it's actually reading in spec with these other two instruments here. And you'll also notice in the table what I've done is taken the millivolt reading from this and converted that to the current that this should then display, or both these two instruments should then display, just to improve the accuracy a little bit more. And you can see that this is sitting a little bit low, but it is within all its specifications, whereas the HT65 just isn't happy at all. So what I'm going to do is just knock this all out of the way and then set up the DC millivolt source that I know will put out exact 200 millivolts, 250 millivolts, etc., which we should be able to confirm with the key sight, and we'll see what readings we get on the instrument then. We're back. Okay, so we're back again. We've set up our DC millivolt source. It's currently switched off, and you can see everything is reading 0. Again, we're on the 40 amp ranges, and this is forced to the 600 millivolt range. If we switch on, we should be injecting 200 millivolts. You can see him down at the bottom there, hopefully. And we've got 199.97 millivolts on our key sight, 19.97 on the Neptune, but 19.58 going down on the HT65. So we'll continue and do these sets of readings as we did before. As long as I don't press anything wrong. So again, good accuracy from our key sight, but you can see HT65 definitely down. It will be 30 amps. And we've got a good comparison. It'll be interesting to see if these are, at the end I'll show the same set of tables as I did before with the current clamp in use, and we'll see how accurate this is in comparison to the actual millivolt source that we're injecting, because this is how the calibration is actually done. The final one, 400 millivolts. There we go, 400 millivolts in there. Sorry, put the light on again. We've got 39.97 greater than 40. So that's petering on its edge, 39.97, which matches 399.97 millivolts from the key site, but only 39.17 on the HT65 there. So this instrument is definitely reading low in comparison to what the calibration sheet says it should be. The calibration sheet was tested, if I remember, at 25 amps, if I think. Let me just grab it. I'll try and put a picture of this up actually, so you can actually see for yourselves. We were looking at DC current without clamp. It's tested on the 30 amp range at 25 amps. So let's just do that. We'll just have to recorrect these instruments and change the range on them, because this one was, pardon me while I go through the ranges. So there's 10 amp, there's our 30 amp range there. Not sure how well we can do this one. Okay, so we've reset our instruments here. We are now, fortunately, the millivolt signalling is different between these two devices, so this 30 amp has gone above range, so I can't utilise this one. But we can compare our U12828A here, which is reading 2.500 volts, so pretty much smack on. And we've got 24.48 amps on our HT65. We're injecting 2.5 volts. So my calibration cert said that the actual reading was 24.87 amps, which is in spec and is higher than what I've got here. And we've got 24.48. The reading should actually be between 24.57 and 25.44. So what I'm getting here with this instrument does not match the readings on this calibration cert, and I'm pretty confident there is definitely something wrong with the current measurement on the HT65. Unfortunately, I've tried in the past, I've tried to get calibration information from HT instruments and they're just not forthcoming with it. I might be able to talk to TIS and see if they can actually adjust calibration and send it to them, but I'm pretty happy that my test setup here is giving me respectable results. This is an independently UCAS calibrated source meter. It is highly accurate. This instrument here is still more accurate than the HT65 anyway, and this is correlating with the source meter, so it seems to make sense to me that the HT65 is the culprit itself. So yeah, we'll have to see what we can do with that, but never mind. That's all there is for this video. Thanks for watching. Hope you found it useful, and I will see you again in the next one.